Hi, myself P. Venkat, faculty at ACE Engineering Academy. So, Airport Authority of India, when you observe the last 5 to 6 years previous year gate papers from engineering mathematics, we will be getting around 20 to 25 questions, sometimes more than 25 questions also. Among all these topics, the highest weightage what I observed from linear algebra, differential equations, calculus. Differential equations means both ordinary and partial differential equations and calculus. So linear algebra means matrices, differential equations including partial differential equations, calculus having highest weightage. Of course, rest of the topics also good weightage, but not those many number of questions we will be given. But from coordinate geometry, there should be around 3 to 4 questions. From probability and statistics, there should be around 4 to 5 questions. And from numerical methods, there should be 1 or 2 questions. From linear algebra, there should be around 8 to 10 questions. Similarly, from differential equations and calculus also, around 7 to 10, they are giving approximately. Now let us briefly review some of the previous year questions. So simple problem, I hope you all people know, total 60 questions and time duration 120 minutes. So the average time for each problem should be approximately 2 minutes. Of course, some problems will take less than 1 minute, some problems will take only 10 seconds, some problems may take 3 minutes or 4 minutes. So on an average, we have to maintain the time, the average time for each problem should be around 2 minutes. Now look at this problem. This is very simple question and we were asked to identify, and look at this. The following differential equation, a into d square y by dx square plus p into d square y by dx square plus whole square plus cxy equal to 0. So we were asked to find order of a differential equation but not degree. Order of a differential equation means among all derivatives, which is the highest ordered derivative you need to identify. Highest ordered derivative is second ordered derivative. So order of the differential equation is 2. Suppose you are asked to find second order. Suppose you are asked to find degree of a differential equation, then we have to identify power of highest ordered derivative, that is degree. But anyhow, we just need order of a differential equation, that is second order differential equation. Simple problem. And observe this. Previous year Airport Authority of India question, let capital A be an n by n matrix from the set of numbers a cube minus 3a square plus 4a minus 6i equal to 0, where I is an n cross n, I mean n by n identity matrix. If A inverse exists, then what would be the value of A inverse? Remember everyone, whenever you are asked to find inverse of a matrix or higher powers of a matrix, suppose you are asked to find inverse of a matrix or higher powers of a matrix, but options must be powers of A and I, that problem should be solved using Cayley-Hamilton theorem. So Cayley-Hamilton theorem, we know every square matrix satisfies its own characteristic equation, but anyhow here we can directly solve that. So we were given a cube minus 3a square plus 4a minus 6i equal to 0. Actually, we want A inverse. So we have to multiply both sides of this equation by A inverse. Then this is A inverse into a cube minus 3a square plus 4a minus 6i equal to 0. Now you observe A inverse into a cube, that is a square, minus 3 into A inverse into A square, that is A minus 3A, plus 4 into A inverse into A identity matrix, minus 6 into A inverse into I, that is A inverse, that is equal to 0. So from this we just have to find 6A inverse. So from this 6 times of A inverse equal to, I mean minus 6A inverse will go right, then it is A square minus 3A plus 4I. So from this what is A inverse? Therefore A inverse equal to 6 will go right side, then it becomes 1 by 6 into A square minus 3A plus 4I. A square minus 3A plus 4I. Now let us verify the options. 1 by 6 into A square minus 3A plus 4I. So 1 by 6 we have only in option D. So by default option D, A square minus 3A plus 4I. So option D will be the right answer. You observe this, what we were given. The product of two eigenvalues is 16. What would be the third eigenvalue? We all know that according to properties of eigenvalues, determinant of a matrix is equal to product of eigenvalues. So this is a 3 by 3 matrix. It will have 3 eigenvalues. Among those 3 eigenvalues, we were already given 2 eigenvalues, and I mean product of 2 of the eigenvalues was already given to be 16. Third eigenvalue we don't know. Let it be lambda. So then product of the eigenvalues equal to determinant of a matrix according to the property. So what is the property? We know determinant of a matrix is equal to product of the eigenvalues. So product 3 by 3 matrix will have 3 eigenvalues. Among those 3 eigenvalues, product of 2 of the eigenvalues is already given. That is given to be 16. So therefore, meanwhile, let us calculate the determinant of a matrix as well. So here, what is the determinant of a matrix? 6 into 9 minus 1. Next, minus of minus 2, that is plus 2 into minus 6 plus 2. Plus 2 into, we are writing determinant of a matrix, 2 minus 6 equal to, among the product of 3 eigenvalues, product of 2 eigenvalues was already given to be 16. Then it becomes a 16 times of lambda 3. This is equal to 6 into 8, 48. Minus 6 plus 2 minus 6, minus 6 into plus 2, minus 4 into plus 2 minus 8. This is minus 4 into plus 2, this is also minus 8, equal to 16 times of lambda 3. So 48 minus 8, that is 40, 40 minus 8, that is 32. 40 minus 8, that is 32. So 32, 16 times of lambda 3 equal to 32. From this, lambda 3 equal to 32 by 16, that would be 2. So among 4 options, the correct option is option A. So option A is the one more eigenvalue of the given 3 by 3 matrix. So this is one of the problem was given in the previous exam from differential equations from equations reducible to variable separable method. Do you know what type of differential equations must be reduced to variable separable method? Any differential equation that is in the form of dy by dx equal to some function of ax plus by plus c. dy by dx equal to, if x plus y whole square goes to right side denominator, then it becomes a square by x plus y whole square. Then it becomes dy by dx equal to some function of ax plus by plus c. Plus c means plus c value 0. Therefore, it will be converted to variable separable method by assuming x plus y equal to t. So please do remember, to solve that type of differential equation, we have to assume x plus y equal to t. You know, actually we want dy by dx, right? So to get dy by dx, differentiate both sides of this equation with respect to x. Then x derivative 1 plus y derivative with respect to x would be dy by dx equal to t derivative with respect to x will be dt by dx. So from this, dy by dx equal to dt by dx minus 1. dt by dx minus 1. Now take the given differential equation. Y plus x means x plus y only. X plus y whole square into dy by dx x plus y whole square into dy by dx equal to a square. So from this dy by dx equal to a square by x plus y whole square. So from this I can write dy by dx equal to a square by x plus y whole square. What is dy by dx? dt by dx minus 1. So substitute dy by dx equal to dt by dx minus 1. This I can write it as dt by dx minus 1 equals to a square by, our assumption for x plus y will be t. So a square by t square. So minus 1 will go that side. Then it becomes dt by dx equal to dt by dx equal to 1 plus a square by t square. So take LCM. This is equal to t square plus a square upon t square. So this is a dt by dx equal to t square plus a square by t square. Variable separable method means all t terms will be taken to one side and all x terms to one side. So from this I will write like this: by cross multiplication t square will go left side numerator, t square plus a square will go left side denominator into dt. By cross multiplication dx will go right. So there is no direct integration formula for t square by t square plus a square. That's why this numerator t square should be written as t square plus a square minus a square. T square plus a square minus a square. Then the numerator becomes t square plus a square minus a square upon t square plus a square into dt equal to dx. Now t square plus a square by t square plus a square cancel, we get 1. So this is equal to 1 minus a square by t square plus a square into dt. I have just to split the fraction, separating the terms t square plus a square by t square plus a square minus a square by t square plus a square. This is equal to dx. Now integrate both sides. Integrating both sides. Tell me integral 1 into dt. Integral 1 into dt dt minus a square by integral t square, integral 1 by t square plus a square. Integral 1 by t square plus a square into dt equal to 1 by a into tan inverse t by a. So this is 1 by t square plus a square is 1 by a. I will write a here. 1 by a into tan inverse t by a. Tan inverse t by a equal to integration of dx is x plus c. This denominator 1a, numerator 1a cancel. So what are the terms remaining? Our assumption for t is x plus y, you write that. Our assumption for t is x plus y minus a into tan inverse of, our assumption for t should be x plus y upon a equal to x plus c. Equal to x plus c. Now you observe left hand side this x, right hand side this x cancel each other. Write rest of the terms. This is y minus a into tan inverse x plus y by a equal to c. But look there, is it there in the options? I don't think so. It is there in the options. We don't have tan inverse first. So inside the tan we have y minus c by a, y minus c by a inside the tan, and we don't have tan inverse. That means still we have to simplify. So first of all, y minus c. Let us do one thing. Take this fraction, take this term to the right, and here c is there. Take this c to the left. Then it becomes y minus c equal to a into tan inverse x plus y by a. A into tan inverse x plus y by a. Now take this a to the left. Then it becomes y minus c by a equal to tan inverse x plus y by a. So this tan inverse, if it goes to left side, it becomes tan. Take tan both sides. Then it becomes tan of y minus c by a equal to, this is x plus y by a. So from this find the value of x plus y. A will go left side numerator. So from this I will write finally x plus y equal to, here a will go left side numerator, then it is a into tan y minus c by a into tan y minus c by a. So x plus y equal to a into tan y minus c by a. X plus y equal to a into tan y minus c by a. So it is matching with option A. So option A is the right answer. That is what I am saying. Average time for each problem should be exactly 2 minutes. Some problems will take only 10 seconds. Some problems half minute. Some problems 1 minute. Some problems 3 minutes. The only thing we have to manage the time in the exam. So now you observe this, we can answer directly by looking at the question answer option D, because it is a Euler's theorem concept. Please observe this. Do you know answer 0? a reason step by step I will explain, but if you have enough concepts, by looking at the question we are able to answer 0. Look, reason I will let you know. See here, any function which we can express, in the form of x to the power of n into some function of y by x, or y to the power of n into some function of x by y, then it is a homogeneous function of degree n. If it can be expressed like this, or if it can be expressed like this, then it is a homogeneous function of degree n. Now you look at the given question. This is u equal to, now you observe the given question. This is u equal to, this is y to the power of n. Y to the power of n means y to the power of 0. Y to the power of n into some function of x by y. Y to the power of n into some function of x by y. Y to the power of n value 0 into some function of x by y. Therefore, it is a homogeneous function of degree n. N means 0. Now it is x to the power of 0 into, this is x to the power of 0 into some function of y by x. X power 0 into some function of y by x. X power 0 means x power n value 0 into some function of y by x. Therefore, it is a homogeneous function of degree 0. So, if you assume this is f of xy and this is g of xy, then f of xy and g of xy both are homogeneous functions of degrees 0 only. F of xy and g of xy are homogeneous functions of degrees 0s only. Therefore, according to Euler's theorem, if f of xy and g of xy are homogeneous functions of degrees m and n respectively, then x dou u by dou x plus y dou u by dou y is m into f of xy plus n into g of xy. M is degree of f of xy, n is a degree of g of xy. That is Euler's theorem formula. By using that, directly we can write here f of x comma y and g of x comma y are homogeneous functions of degrees 0s respectively. Therefore, what is Euler's theorem formula? Therefore, Euler's theorem formula is x into dou u by dou x plus y into dou u by dou y equal to m into f of xy plus n into g of xy. M into f of xy plus n into g of xy, it is a Euler's theorem formula. So, m is a degree of f of xy, n is a degree of g of xy. So, f of xy degree 0, g of xy degree is also 0. I mean m0, n0. This is 0 into f0 plus 0 into z, 0. So, therefore, final answer is 0. The function w equal to log z is analytic everywhere, complex variables, except at the value of z, then z is. So, logarithm of z is analytic everywhere except one particular point. What is that particular point? You have to choose from the options. Do you know? So, if you solve as per the procedure, it may consume time. That's why the easiest way that you have to remember is the point at which the function is undefined. The point at which the function is undefined, I mean the function becomes infinity. at that point the function will not be continuous, will not be differentiable, will not be analytic. So in this case, as we all know that log z is undefined when z equal to 0, means log 0 undefined. So therefore, if w equal to log z is not analytic at z equal to 0, means log z is analytic for all z values greater than 0. Log z may not be analytic, log z will not be analytic at z equal to 0, will not be analytic when z less than 0 in some of the cases. This is also the complex variables, and we were asked to write the Taylor series expansion of 1 by z minus 2 in the region mod z less than 1. What is the Taylor series expansion of 1 by z minus 2 in the region mod z less than 1? Do you know mod z less than 1 you are given, but we have to write 1 less than 2. We have to write mod z less than 2. What is the purpose of writing mod z less than 2? Here the denominator is z minus 2. That's why you have to write 1 less than 2. For example, denominator is z minus 3. It should have been 1 less than 3. So the region is now mod z less than 2. If mod z less than 1, now 1 is also less than 2. If mod z less than 1, 1 is less than 2. If mod z is smaller than 1 and 1 is smaller than 2, I am assuming mod z less than 2. Now you observe. Actually, whenever the statement of the given problem does not contain trigonometric or hyperbolic or logarithmic or exponential functions, in all such cases, the given function can be expanded as a Taylor series or Lorentz series, whichever it is possible, no issues. That should be expanded using binomial expansion. Do you know binomial expansion is valid in which region? Binomial expansion is valid in the region mod x less than 1. That is okay. And do you know that binomial expansion 1 minus x whole to the power of minus 1 or 1 plus x whole to the power of minus 1? That is the binomial expansion. Whichever is required, we can adopt that. So now, do you know this binomial expansion is valid in the region mod x less than 1? This binomial expansion is valid in the region mod x less than 1. So you are already given mod z less than 1, but the denominator is z minus 2. That's why I have written 1 less than 2. But we all know that binomial expansion is valid in the region mod x less than 1. So therefore, it should also be not this, it should also be brought to the form of mod x less than 1. How can you make it as less than 1? Very simple. Divide both sides by 2. Divide both sides by 2, mod z by 2. Actually it is mod z by 2. I will write 2 inside the modulus because mod 2 is 2 only. So therefore, mod z by 2 less than 1. Mod z by 2 less than 1. Please remember this is mod x. This is mod x less than 1. So what is x value? Z by 2. That means we need a series expansion in terms of z by 2. Series expansion required in terms of z by 2. Please remember that you are given 1 by z minus 2. You are given 1 by z minus 2, and moreover series expansion is required in terms of z by 2. Series expansion required in terms of z by 2, and at the same time your binomial expansion should be in the form of either 1 plus x whole power minus 1 or 1 minus x whole power minus 1. So that's why How can you make it as z by 2? To make it as z by 2, generally we people have a doubt that, sir, 2 will be taken out as common. Remember, if I take 2 common, then it becomes z by 2 minus 1. To make z as z by 2, you people have a doubt that 2 will be taken out as a common. We will get like this. But you know one thing, statement of the given problem does not contain trigonometric or hyperbolic or logarithmic or exponential. In all such cases, binomial expansion should be used to write either Taylor series or Laurent series. Binomial expansion should be used, that is in the form of 1 minus x. That's why we have to make it as 1 minus x. Let it be x. To make it as 1 minus x, this is 2 into, but actually our binomial expansion is required in terms of 1 minus x. That's why take minus symbol common, then it becomes 1 upon minus 2 into 1 minus z by 2. Now take the denominator function in the numerator, then it becomes minus 1 by 2 into 1 minus z by 2 whole to the power of minus 1. 1 minus z by 2 whole power minus 1. This is equal to minus 1 by 2 into, have you seen the formula 1 minus x? 1 minus x whole power minus 1. 1 minus x, this is x. Treat it as x. So what is the formula? 1 minus x whole power minus 1 formula, 1 plus x. 1 plus x, x means z by 2, plus x square by 2 plus x square means z by 2 whole square, means z square by 4, plus x cube means z by 2 whole cube means z square by 8, plus so on. Observe this and look at the options. Minus 1 by 2 into 1 plus z by 2 plus z square by 4 plus z cube by 8. Sorry, this is z cube. Z cube by 8 so on. Therefore, option B is the right answer. Plus 1 series expansion is there. Now you observe this problem was given from Gauss divergence theorem, vector calculus. Do you know the scalar form of Gauss divergence theorem was given? Double integral f1 dy dz plus f2 dz dx plus f3 dx dy. That is the scalar form of Gauss divergence theorem. What is scalar form of Gauss divergence theorem? Remember, in any competitive exam, name of the theorem will never be specified. You people should only have to remember the application of each particular theorem. I mean, when it should be used and whenever it is required, you must be able to apply. This problem is related to Gauss divergence theorem. What is Gauss divergence theorem? Scalar form. This is the scalar form of Gauss divergence theorem. Double integral f1 dy dz plus f2 dz dx, f2 dz dx plus f3 dx dy. So this is equal to triple integral, I mean volume integral, dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z dx dy dz. This is the Gauss divergence theorem formula. Please do remember that. Now we take the given question, answer 0, but anyhow, see, among 4 options, if one of the option is 0, generally there is a chance for the answer to be 0, but without checking, you should not blindly put answer 0. What is the given question? Yz dy dz plus xz dx dz plus xy dx dy plus xy dx dy. So assume this is f1, let it be f1, let it be f2, let it be f3. So what is the formula? This is equal to double integral f1 dy dz. What is the formula? Triple integral dou f1 by dou x. Observe this. Triple integral dou f1 by dou x. Dou f1 by dou x means f1 derivative with respect to x partially 0 plus dou f2 by dou y. F2 derivative with respect to y partially 0 plus dou f3 by dou z. F3 derivative with respect to z partially 0 into dx dy dz. So 0 plus 0 plus 0, that is 0. So therefore, triple integral 0 dx dy dz should be 0. So the problems will be given in such a way that we are able to do on an average within 2 minutes only. Now you observe the minimum value of the function x to the power of x exists when x equal to dash. So the question is, for what value of x the given function will have the minimum value? Very simple. First of all, the given problem, let it be y. The given question, let it be y. To find the maxima and minima, first of all, we have to find dy by dx and d square y by dx square. But directly we can find dy by dx, but it is quite comfortable to take logarithms both sides before going to find dy by dx value. That's why let me take logarithms both sides, then it becomes ln y equal to ln x to the power of x. So ln y equal to ln x to the power of x can be written as x into ln x. So differentiate with respect to x both sides, because to find the maxima and minima, first of all we have to find the stationary point or critical point. To get the stationary point, find the first derivative. Once we get the first derivative, you need to identify the point at which the given function becomes either 0 or infinity. That is called critical point. Stationary point means the point at which f dash x is 0 is a stationary point. Critical point means the point at which either f dash x is 0 or f dash x infinity is called critical point, because maxima and minima occur at critical points only. That's why we have to find the critical point first. For that, we need to differentiate with respect to x both sides. Ln y derivative 1 by y, and again y derivative with respect to x dy by dx, that is equal to uv rule. This is u, this is v. U, v derivative. x into ln x derivative 1 by x plus ln x into x derivative 1. So once again let me write this expression 1 by y into dy by dx equal to, so x cancel, then it is 1 plus ln x. By cross multiplication y would go right side numerator, then it becomes dy by dx equal to y into 1 plus ln x. Y cannot be 0. Everyone should remember, to get the stationary point we need to identify the point at which the given function becomes 0. So y cannot be 0. First you write like this, to get the stationary point first you have to equate dy by dx to 0. dy by dx is 0 means that is y into 1 plus ln x equal to 0. Y cannot be 0. If y can be 0, statement of the given problem is 0, then nothing can be solved. So that's why y cannot be 0. The next choice is 1 plus ln x will be 0. From this, ln x equal to minus 1. So from that, x equal to e power minus 1. ln x equal to minus 1. So from this is ln x to the base e. So from this x equal to e to the power of minus 1. Do you know maxima and minima occur at critical points? I mean occur at stationary points. We got only one critical point. We got only one stationary point. And maxima and minima occur at stationary points only. They said the function having a minimum value. So the minimum value occurs at which point? Minima and maxima occur at stationary points only, but we got only one stationary point. Obviously that minima should occur at this stationary point only. So no need to check whether d square y by dx square greater than 0 at x equal to e power minus 1. Because the point at which dy by dx is 0 and d square y by dx square greater than 0, at that point the function will have a minimum value. But here no need to find, directly up to here, that is the stationary point. Therefore it has minima at x equal to e to the power of minus 1. So complex variables, we were asked residue of cos z by z. Do you know cos z by z at z equal to 0? Remember everyone, the coefficient of 1 by z minus z naught in the Lorentz series expansion is called residue of f of z at z equal to z naught. Coefficient of 1 by z minus z naught at z equal to z naught is called residue of f of z at z naught. So that's why I give the first priority for writing the series expansion whenever it is possible to calculate the residue. So from this is equal to 1 by z into, do we know the series expansion of cos z means cos x or cos z series expansion 1 minus z square by 2 factorial plus z power 4 by 4 factorial minus z power 6 by 6 factorial plus on. So now multiply each and every term of the bracket function with 1 by z. Then it becomes 1 by z into 1. 1 by z into 1, 1 by z. Next 1 by z into z square by 2 means z by 2 factorial will be 2 plus z power 4 by z, that is z cube, by 4 factorial means 24. What is residue I said? Residue means 1 upon z minus z naught coefficient is the residue. 1 upon 1 by z minus z naught. Z naught means what? 0. Z minus 0. 0 is z naught. 1 by z minus 0, z minus 0, z minus 0, so on. So therefore, 1 by z minus z naught means 1 by z minus 0 coefficient is the residue of f of z. Residue of the given function f of z means cos z by z at z equal to z naught. Z naught means 0. At z equal to z naught means 0 is 1 by z minus z naught. 1 by z minus z naught means 0. 1 by z minus z naught coefficient will be the residue. We were asked the solution of the differential equation. D square y by dx square minus 3 dy by dx plus 2y equal to e to the power of 3x. So let us see the solution of the differential equation is, first we have to write the auxiliary equation. How do you write auxiliary equation? Y coefficient is equated to 0, means d square by dx square, also written as d square minus 3 into d by dx is capital D plus 2. D by dx can be assumed as capital D. So d square minus 3d plus 2 equal to 0. Therefore, what are the roots? 1, 2. Do you know if two roots are real numbers as well as different numbers, then what is the complementary function? C1 e power m1x plus C2 e power m2x will be the complementary function. Instead of m1 and m2, instead of C1 and C2, they took it as A and B. No issues. So complementary function is C1 e power m1x. This is m1, this is m2. Or this is m1, this is m2, no issues. C1 let it be A. C1 e power m1x plus C2 let it be B, C2 e power m2x. This is m1, this is m2. Now particular integral among 4 options, because in the exam also you people have to solve the problem as per the options only in order to save the time effectively. Among 4 options, how many options complementary function part is a e power x plus b e power 2x? Look there, option A, only option A complementary function part is a e power x plus b e power 2x. No other options complementary function is containing a e power x plus b e power 2x. Therefore, without finding particular integral, directly we can say option A is the right answer. This you must be careful in the exam, because sometimes options would be helpful in order to select the right option without doing the problem completely. So remember that. Anyhow, I am teaching particular integral as well. Particular integral equal to 1 by dependent variable coefficient means y coefficient means d square by dx square minus 3 into d by dx plus 2y y coefficient 2 into right side of the given differential equation, that is e to the power of 3x. Do you know the particular integral containing exponential function that comes under type 1? To solve type 1 particular integral, d should be replaced by alpha. Alpha means what? E to the power of alpha x, alpha value 3. So d should be replaced by 3. Alpha means 3. Therefore, this is equal to 1 by d should be replaced by 3. Then it is 3 square minus 3 into 3 plus 2 into e to the power of 3x. 3 square 9 minus 3 into 3 9, 9 minus 9 0. So 1 by 2 into e to the power of 3x. Do you know general solution is complementary function plus particular integral. Add both, you will get the general solution. General solution is y equal to complementary function plus particular integral. A e power x plus b e power 2x plus 1 by 2 into e to the power of 3x. This is the general solution. Look at this problem. Do you know this is quasi-linear partial differential equation, and it should be solved using Lagrange's method of grouping. Do you know in this quasi-linear partial differential equation, small p stands for dou z by dou x, I mean del z by del x, and small q stands for dou z by dou y. What is the general form of quasi-linear partial differential equation? The general form of quasi-linear partial differential equation is capital P into small p. Capital P is small p is dou z by dou x. Capital P is some function of x, y, z plus capital Q into small q. Small q means dou z by dou y. Capital Q is some function of x, y, z. Even capital R should also be some function of x, y, z. So from this, the given problem is p root x plus q root y equal to root z. Small p into root x plus small q into root y equal to root z. So here capital P equal to root x, capital Q equal to root y, and R equal to root z. What is the Lagrange's auxiliary equation? Lagrange's auxiliary equation is dx by capital P equal to dy by capital Q equal to dz by capital R. This is a Lagrange's auxiliary equation. Substitute PQR values. Lagrange's method of grouping is required to solve this. So this is dx by P means root x. This is equal to dy by Q means root y equal to dz by R. R means root z. Once again, look at the options. All options, one of the solution is all options, one of the solution containing root x plus containing x and y terms. All options, one of the solution is x and y, containing x and y. So therefore, to get the solution also in terms of x and y, we have to consider the fractions involving dx and dy. We have to consider the fractions involving dx and dy. So it is a dx by root x equal to dy by root y. Integrate both sides. Here integration symbol, here integration symbol. Integral 1 by root x dx is 2 root x. Integral 1 by root y dy is 2 root y. Integration completed, add some constant, let it be c. Let it be c. So divide both sides by, or take 2 root y to the left, then it is 2 root x minus 2 root y equal to c. Divide both sides by 2, then it becomes root x minus root y equal to root c. this is c by 2. So c by 2, let it be u. This is our first solution. First solution assumed. Assume the first solution as u, that is root x minus root y equal to c by 2, let it be c1. C by 2, let it be c1. So among 4 options, how many options containing one of the solution as root x minus root y? Let us verify. Among 4 options, so unfortunately 2 options containing root x minus root y. So these are eliminated. To identify what is the another option, we can select in these 2 options second function containing root x root z. So therefore we have to get the solution in terms of x and z, we also have to select the fractions involving dx and dz. Fractions involving dx and dz, that is obvious. Directly we can say option B is the right answer. Because if I take, observe this, because if I take dx by root x equal to dy by root y, I got one of the solution as root x minus root y. If I take dx by root x equal to dx by root z, obviously another solution should be root x minus root z. Obviously another solution should be root x minus root z. In the similar manner, if you want, you can select dx by root x equal to dz by root z and simplify. Definitely you will get this. The value of x for which the matrix is singular. Do you know singular matrix? Singular matrix means det 0. So you can find you can solve det equal to 0, you will get the answer option B. Simply find the determinant of a matrix, you will get option B. But I will teach a technique, you solve as per the procedure. Det equal to determinant of a matrix equal to x plus lambda xx xx plus lambda x x x x plus lambda. To find the determinant of a matrix, you solve this det as per the procedure. The technique of finding, I will let you know. As per the procedure, you people can try. Remember, if you come across a square matrix in which diagonal elements one category of same elements, a square matrix in which diagonal elements one category of same elements and non-diagonal elements other category of same elements. Remember, a square matrix in which diagonal elements one category of same elements, non-diagonal elements other category of same elements. To find the determinant of that type of matrices, select only first row. This is not a procedure. According to the procedure, you can solve it later. This is just a technique of writing the answer, and when this technique is applicable, if you come across a square matrix in which diagonal elements one category of same elements, non-diagonal elements other category of same elements, to find the determinant of that type of matrices, select the first row. You can select any row. For convenience, select the first row. Then add all elements of the selected row. Then add all elements of the selected row. Add all elements of the selected row means what? X plus lambda plus x plus x. Then add all elements of the selected row into means x plus lambda plus x plus x. Next, first element minus second element. First element minus second element, that is x plus lambda minus x into second element minus first element minus second element into first element minus third element, into first element minus third element, that is x plus lambda minus x. Select the first row, add all elements of the first row into first element minus second element into first element minus third element. This is a technique only. As per the procedure, you can solve it later. It is simply 3 by 3 matrix that only. This is 3x plus lambda plus x minus x cancel, plus x minus x cancel, lambda square. But they said matrix is singular. Matrix is singular means delta 0. Delta 0 means this value 0, lambda square into 3x plus lambda equal to 0. The question is, for what value of x the matrix is singular. So therefore lambda square useless, then simply 3x plus lambda equal to 0, 3x equal to minus lambda, therefore x equal to minus lambda by 3. Therefore the value of lambda for which the matrix becomes a singular matrix is minus lambda by 3. Minus lambda by 3. So this is a calculus definite integral problem. Remember, if you come across any integral, whose lower and upper limits are in the form of minus a to plus a, any integral that we come across in the form of integral minus a to plus a, then we need to check whether integrand is even function or odd function. Remember, anything inside the modulus is always even function only. Anything inside the modulus is always even function. So therefore it is even function. So according to properties of definite integrals, integral minus a to a f of x dx can be written as 2 times of integral 0 to a means 1 into e to the power of mod x dx. But we all know mod x equal to plus x when x greater than 0. So 0 to 1 means what? X greater than 0 region only. So for all x values greater than 0, mod x value plus x only. Integration of e power x dx is e power x only between the limits 0 to 1. Between the limits 0 to 1, so replace x by upper limit 1 minus lower limit 0. 2 into e power 1 minus e power 0, that is 2 into e minus 1. So option B is the right answer. It's a direct formula. The value of integral 0 to pi by 2 sine power 7x cos power 4x dx is equal to. Very simple. Do you know this formula? So this is one of the properties of definite integrals. The formula should be integral 0 to pi by 2. Integral 0 to pi by 2 sine power mx cos power nx dx. What is the formula for this? The formula for this is m minus 1, m minus 3, m minus 5, so on 1 or 2. Means we can expand in this manner until the last term appears either 1 or 2. Until the last term appears either 1 or 2. Similarly, n minus 1, n minus 3, n minus 5, n minus 7, so on. Expansion is required until the last term becomes either 1 or 2. Close the bracket into k. Divided by denominator, what do you have? Denominator is m plus n, m plus n minus 2, m plus n minus 4, so on, into 1 or 2. Do you know what is k? K value pi by 2 if both m and n are even numbers. Suppose both m and n are even integers, k value pi by 2. Otherwise, k value 1. Otherwise means what? Both m and n are not even integers. Means m even, n odd, m odd, n even, both m and n odd. In such cases, k should be replaced by 1. So remember the formula. Now, we directly apply that formula here. Integral 0 to pi by 2 sin power mx, m value 7, cos power nx, n value 7. Integral 0 to pi by 2 sin power mx, cos power nx dx. Then what is the formula? The formula is, you have seen first bracket m minus 1, m minus 3, so on, until the last term becomes either 1 or 2. In the same manner, second term also m minus 1, m minus 1, m minus 3, m minus 5, m minus 5, 2. If last term becomes either 1 or 2, stop there itself. Next to n minus 1, n minus 1, n minus 3. You can expand like this until the last term becomes either 1 or 2. Denominator, what do you have? M plus n. Denominator m plus n, 11, plus m plus n minus 2, 11 minus 2. M plus n minus 4, 11 minus 4. 11 minus, next to 5, next to 3, 1. You can expand like this until the last term becomes either 1 or 2. Into k. What is k value? K value 1 if both m and n are even integers. Otherwise, k value should be 1. So we have to simplify this. So here 3 cancel. Here 3 threes, 3 twos. Then it is 2 into 4, 8, 8 into 2, 16 upon 11 into 3, or 5 into 7, 35. 35 into 3, 35 into 3, 105. 105 into 11. 105 into 11, that is 1155. This problem also option B correct. 16 by 1155. So this problem was given from method of variation of parameters but we were asked only the value of Wronskian determinant, which is also simply called Wronskian determinant. So now, what is the given differential equation? Given differential equation is a dy double derivative, means what? D square y by dx square minus 2 into y derivative means dy by dx plus y equal to 0. Sorry, plus y equal to e to the power of x into log x. But to get the Wronskian determinant, this right side not required. First, let us find complementary function. Because Wronskian determinant W value can be determined from complementary function only. So that's why we have to write the auxiliary equation first. What is auxiliary equation? Just a dependent variable coefficient is equated to 0. What is dependent variable? Y. Y coefficient is equated to 0. D square by dx square minus 2 into d by dx plus y coefficient 1 equal to 0. Then it is d square minus 2d plus 1, that is d minus 1 whole square equal to 0. So what are the roots? 1 comma 1. Do you know if two roots are real numbers as well as repeated numbers? Let it be m1, let it be m2. Then what is the complementary function? C1 e to the power of m1x plus C2 e power m2x. C1 plus C2x into e power m1x, sorry. Then the complementary function is C1 plus C2x into e to the power of m1x. m1 value 1. But I want to write like this equal to C1 into e to the power of x plus C2x e to the power of x. Do you know this e to the power of x and x e power x are called linearly independent solutions of the differential equation? So this let it be y1, this let it be y2. So what are y1 and y2? y1 and y2 are linearly independent solutions of the differential equation. What is the Wronskian determinant? We define. Wronskian determinant is defined as first row y1 y2, second row y1 dash y2 dash. Substitute y1 is e power x. So Wronskian determinant, also called Wronskian determinant, first row y1 e to the power of x, y2 that is x e power x, second row y1 dash, y1 is e power x, y1 dash is e to the power of x, y2 dash, this is y2, y2 dash means what? Derivative of x e power x. We can find derivative of x e power x by using UV rule. This is u, this is v. U, v derivative. X into e to the power of x derivative, e power x, plus e to the power of x into x derivative, 1. So find the determinant of this matrix, e power x into x e power x, that is x e power 2x, plus e to the power of x into e to the power of x, e to the power of x plus x, that is e to the power of 2x, minus e power x into x e power x, that is x e to the power of 2x. So here plus x e to the power of 2x minus x e to the power of 2x cancel each other. Therefore, what is the particular integral? E to the power of 2x. Sorry, not particular integral, Wronskian determinant. E to the power of 2x. Do we have the option? Yes, that is e to the power of 2x. Look there. So this is a conceptual question. Observe that carefully. If capital A is a square matrix of order n, the inverse of exists. If the inverse of A inverse exists, if, remember everyone, inverse of A inverse exists only when, remember everyone, inverse of a matrix exists only when determinant of a matrix is not equal to 0, because A inverse formula adjoint A by det A. If det A not equal to 0, then only A inverse exists. So therefore, inverse of a matrix exists only when det A not equal to 0. Do you know determinant of a matrix is also equal to product of eigenvalues? Determinant of a matrix is equal to product of eigenvalues. So product of eigenvalues is not equal to 0. Even one eigenvalue 0, that will be 0. Means these three eigenvalues will not be zeros. All are non-zero eigenvalues only. So 1 is not an eigenvalue of A. How can you say that exactly 1 is not an eigenvalue? How can you say that exactly 1 is an eigenvalue? So 0 is not an eigenvalue of A. A inverse. See that A inverse exists. If 0 is an eigenvalue of A inverse does not exist because det cannot be 0. So for the A inverse to exist, 0 is not an eigenvalue of A. 0 should not be an eigenvalue of A. Then only A inverse exists. Then only det A not equal to 0. This is simply Cauchy's integral theorem. What is Cauchy's integral theorem? Suppose, Cauchy-Gauss theorem states that suppose f of z is analytic inside a simple closed curve and also on a simple closed curve, then Cauchy's integral theorem states that integration of f of z dz around the closed curve, integration of f of z dz around the closed curve is not equal to 0. So therefore option B is the right answer. Cauchy's integral theorem statement was given. Do you know this is from partial differential equation? You know f suffix xx means dou square f by dou x square. F suffix yy means dou square f by dou y square. F suffix xy means dou square f by dou x dou y. This is simply, this problem is related to classification of second order linear partial differential equation. Do you know second order linear partial differential equation general form? A into dou square u by dou x square. I think you know that. Anyhow, I will write A into dou square u by dou x square plus B into dou square u by dou x dou y plus C into dou square u by dou y square plus D into dou u by dou x plus E into dou u by dou y plus fu plus z equal to 0. This is the general form of second order linear partial differential equation. Find b square minus 4ac. If b square minus 4ac greater than 0, hyperbola. less than 0, ellipse, equal to 0, parabolic. So dou square u by dou x square coefficient is A. F suffix xx means dou square f by dou x square. Dou square f by dou x square coefficient is A. So A value 1. F suffix xy means dou square f by dou x dou y coefficient is B. So B value 2. Dou square f by dou x dou y coefficient is B. Next, dou square f by dou y square coefficient is C. Dou square f by dou y square coefficient is C. C value 4. So find the value of B square minus 4AC. B square minus 4AC. B value 2 minus 4, A value 1, A value 1, B value 2, C value 4, C value 4. So this is 2 minus 16, 2 minus 16 less than 0. So B square minus 4AC less than 0, therefore it represents elliptic. We were asked complementary function of the differential equation. Do you know this differential equation belongs to, this differential equation is a Cauchy-Euler linear differential equation. So for Cauchy-Euler linear differential equation, we all know that to solve Cauchy-Euler linear differential equation, x square into d square y by dx square should be replaced by d into d minus 1 into y. Should be replaced by d into d minus 1 into y. Plus 4 into x into dy by dx is dy plus 2y equal to e to the power of x square. This is e power x square. So therefore, y is the common factor, take it out, then it becomes d into d square, d into minus 1, minus d into y, minus dy plus 4 dy, that is 3 dy, y common, so it is 3d plus 2y, y common, so it is 2 into y equal to e to the power of x square. We just need only complementary function. So for that, we just have to write the auxiliary equation. What is auxiliary equation? Just y coefficient is equated to 0. So d square plus 3d plus 2 equal to 0. So from this, what are the roots? From this, the roots are minus 1 comma minus 2. Do you know in this model capital D stands for, regarding Cauchy-Euler linear differential equation, capital D stands for d by dt, not d by dx. So accordingly the complementary function will be. So what is complementary function generally? If two roots are real numbers as well as different numbers, let them be m1 and m2. Then the complementary function is c1 e power m1t. c1 e power m1 into t plus c2 e to the power of m2 into t. But options are not given like that. So we have to modify. Listen to me. We know the assumption in this model, the assumption regarding Cauchy-Euler linear differential equation is log x equal to t. So from this, what is x value? E to the power of t. So from this 1 by x 1 by x means x power minus 1 means 1 by e power t. 1 by e power t, that is e power minus t. So, but actually e power minus t and e power minus 2t. So 1 by x square means x power minus 2. 1 by x square means 1 by e power t whole square. E power t whole square is e power 2t. 1 by e power 2t, that is e power minus 2t. So e power minus t means 1 by x means x power minus 1. E power minus 2t means minus x power minus 2. So complementary function is c1 into x power minus 1 plus c2 into x power minus 2. So among 4 options, only one option contains e power x, c1 x power minus 1 plus c2 x power minus 2. That would be the right option. So we will see in the next session. So because it's time up, we see the remaining problems we'll see in another session. Thank you one and all.
In Gate 22 in electrical engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam. And also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in Gate 22 in electrical engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also